If you watched the previous video on properties of addition, some of these are going to sound familiar. So just like with addition, there are things we can do with multiplication that are sort of alternatives to following the explicit rules of the order of operations. So I'm going to review a few. First one is commutative. That sounds familiar, right? So with the commutative property of multiplication, we can reverse the order. 3 times 5 is equal to 5 times 3. They both equal 15. Algebraically, we can say A times B is equal to B times A. Any number times some other number is equal to the reversal, right? The different order. The second property of multiplication that should sound familiar is associative. And remember, we talked about who do you want to associate with? And so we pick 3 numbers. Let's go 2, 3, and 4. Actually, let's go 3 times 4 times 5. This is a better one. 3 times 4 times 5. Now, the order of operations, if you followed it, would say, well, you have to start by multiplying the first 2 numbers. Work from left to right. 3 times 4 is 12, and then you'd have to multiply 12 times 5. However, you might notice that when you have 3 times 4 times 5, it might be easier if you're doing this in your head to start with the 4 and the 5, because those make a nice, pretty number. 4 times 5 is 20. And then you can do 3 times 20, which is 60. That might be easier to do in your head. So you have some flexibility when it comes to how do you want to execute a big string of multiplication. So again, algebraically, we have 3 different numbers, A times B times C. And if we're going to multiply those 3, we can choose to multiply A times B first, or we could choose to multiply B times C first. And in fact, there are some situations where you could apply both the commutative and associative properties together. What that might look like is, I'll do this off to the side. Let's say we had 2 times 7 times 5. Let's say that's the problem that you have to do in your head. You might say, wow, 2, 7, and 5. 2 and 5 are really nice to multiply together because they make 10. So maybe you might apply the commutative property here and think about it as 2 times 5 times 7. So you're switching the order of the 2 numbers. And then you're going to group the 2 and the 5 together. You're going to choose to do that, which is 10, and then 10 times 7 is 70. So you can apply multiple properties to the same expression, to the same problem. Okay. Remember we had an identity property for addition when we add 0. We also have what's called, I love this word, it's called the multiplicative identity. Multiplicative, just say it, identity. Now, if you remember from addition, identity is when you get what you started with. So now think, well, what do I multiply by to get what I started with? And that is the number 1. So any number, if I take 5 and I multiply it by 1, I get 5. 5 times 1 equals 5. So any number, A times 1 is equal to A, whatever you started with. Often when we, this is just a side note, often when we multiply variables, like the letters, we want to state that symbolically, variables times a number. We often put that number in front of the variable, and we often we usually don't even write the dot symbol. We just put 1A. That notation right there means 1 times A. So 1A is equal to A. That's an important one to know right there. So there's your side note. Now, we need to talk about another law. We're going to have a few more here with multiplication. So I like to call this one the zero factor law. The zero factor law. It's a law. It's a mathematical law. So if you think back to some earlier conversations, we talked about the word factor. And factor is, you think multiplication, right? So when zero is part of a multiplication problem, it's a factor. So this one is also going to be one you just say, duh, to. Let's say we have 7 and we multiply it by 0. 7 times 0 is equal to 0. That's the zero factor law. The zero factor law states that any number, a, times 0 is equal to 0. When 0 is a factor, right? 0 is a factor, something that can be multiplied, the product will be 0, right? So this is the product. If you have a product that is 0, what that means is one of your factors must have been 0. Okay? And that leads us to the final part of this conversation, which is division with 0. Division with 0. So, you can have division with 0 appear in a couple different ways. So I'm going to start with 0 divided by 8, or I'll even write it as a fraction, 0 divided by 8. Okay, these both mean the same thing. We're taking 0 and we're dividing it by 8. Both of these equal 0. You can take the number 0 and divide it by something. You just end up with 0. On the other hand, what you cannot do is this. You can never divide by 0. You can never have 0 follow the division sign. You can never have 0 on the bottom of a fraction. There's a special word for this. When you see this, or if this ever happens, this is what we call undefined. It is undefined. If you try to calculate it on a calculator, if you try to type it in, you will get an error message. 9 divided by 0 cannot divide by 0. That's what the Windows calculator says. Let's ask Siri. Hey Siri, what's 9 divided by 0?
Please don't make me divide by 0. That would be like me asking you to grow a third arm.
Siri doesn't like that. Siri even says it's undefined. It's impossible. And the reason it's impossible goes back to the zero factor law and what division actually means. I'm going to take one extra second and show you the why behind this. So think back to our conversation about multiplication and division. Remember 3 times 5 equals 15, so we can turn that around and say 15 divided by 5 is equal to 3. Right? We can take this and sort of work it backwards with division. It undoes it. So if we have 7 times 0, we know by the zero factor law that that equals 0. Okay? But if we try, let's turn it around. Let's say we want to do 0. I want to try to do 12 divided by 0. Let's just say I want to try to do that, right? That's the question that I'm trying to answer. Well, if I'm trying to do 12 divided by 0, and that gives me some answer, what that means is that I had some sort of original answer that when I multiplied it by 0, it gave me 12, right? It's sort of working backwards, right? Remember 3 times 5 equals 15. So 15 divided by 5 must be 3. Well, if you can do 15 divided by 5, that means there was something you started with. So if I'm trying to do 12 divided by 0, it means that I started with something, multiplied it by 0, and got 12 as an answer. Can you think of any number that when you multiply by 0, you get 12 as an answer? No. Because the zero factor law states that anything multiplied by 0 must equal 0. So to try to divide by 0 is breaking the mathematical law. So that's why we can't divide by 0. And I want you to know that word. I need you to know that that is called undefined. Undefined anytime you want to divide by 0.